Hello everyone and welcome back to the YellowDog 3D Tips blog. Today I'm going to be showing you how we can do some motion capture inside of PFTrack. This is the clip that we're going to be tracking, so we're going to be getting perfect 3D positions of all the points on that piece of paper. This is my beautiful colleague Ed, who agreed to help me out with this tutorial, so cheers Ed. Obviously it's not a full body motion capture, but it's the exact same principles as that, so if you learn this technique you'll be able to do a full body motion capture if you so please. Here's a quick example of something I put together with the motion capture data we'll be creating in this tutorial. I basically textured the piece of geometry that was outputted by PFTrack and textured it with the original footage. Once it was textured, I sort of ran out some renders and sort of iterated it a few times, so you get that sort of Hall of Mirrors effect. As you can see, it's quite rough. I didn't spend much time on it, but you get the idea. I've just got PFTrack open now, and I'm just going to create a new project. So I'll just call this one Mocap 01 and click Create. And first things first, we just need to navigate to our footage. So I've got these three pieces of footage here, and I'm going to drag these into the work area. For motion capture to work, you need at least one witness camera, which witnessed the same sort of motion as the original. So this is my original footage shot on the Sony FS7, and my witness camera footage is just shot on the iPhone 7 Plus. And I've undistorted the footage already inside of Nuke. And if you want to learn how to undistort your footage, there's already a YellowDog 3D tips on match moving, and it's included in that. So straight away inside of PFTrack, we've got to set the film back size. And if you go to VFX camera database, you can get the sensor dimensions of the camera you shot with. So I've just double clicked the main cam. I'm going to go to camera preset and go to custom and just set the film back size. I already set this up. So the next thing we need to do is track our main footage. So we're just going to use an auto track for this. And obviously there's a lot of moving things in this shot. So I need to go to the mask tab and just start drawing a roto around him. I've used the Bezier roto option. And if you just move along the timeline, it will just keyframe automatically. And if you press Control, you'll get this sort of transform display, so you can move the whole thing as one. So I just fast forwarded the video and I finished this mask. So this should be good to track now. So I'm going to go back to the parameters and I'm going to start filling in these fields. These are obviously going to be unique depending on what shot you are tracking. So I put in the candidate number 80, target number 60, window size 40, search range 80. I put the failure threshold up to 0.85 and the minimum length up to 20, and I've just clicked blur image and I'm just going to let this auto track run through. So that's finished now, and it looks like we've got some pretty solid points in there, and this should work pretty well for a camera solve. Next I'm going to add a user track on the end of this auto track, and this is where things get a little bit interesting. I'm going to connect all of my footage to this one user track. So if I just get the little tab and add it to this little plus icon on the user track, and just pipe them all into the same one. And the general idea here is to track points that appear on both clips or all three of the clips. So you can switch between your clips and cross-reference them using this current clip drop-down. So I'm going to click create and create a new tracker on this back window because I've seen that it appears in all three of the clips. And because this camera is stationary, we don't actually need to track it, we can just position it on the feature. And once I've created that, I'm going to switch to a different camera and untick create, that's very important, and I'm just going to click on the footage and position this tracker where it should be, and you'll see that under clips it's now added to both of them, and this tracker only appears for a few frames in the main clip. So if we hit hide backwards at the bottom, that's going to make the tracker disappear sort of when it's not in frame. We don't want the tracker just to be floating around doing nothing. That's going to mess up the track. So if I hit hide forwards now, you'll see that the tracker only appears when that feature is in shot. So I'll just start adding some more trackers. So I know that the printer is in shot on all three of the cameras. So if I click the little create box and then create a new tracker, you'll see a new tracker will appear under the tracker field. And I'm just going to track this for this shot. So I'll just track forwards and I'll let that run through. So here we are, I've tracked that for the entire length of the clip, and now I can go into my other cameras and find that same point. Remember, we don't need to track these points because the camera doesn't move, so I'll just move to a point where I can actually see that point on the printer, which is just this little white thing. I'm not really sure. That's definitely the point. So we go to the left camera and I'll just position a tracker there, and it sticks in for the whole thing because the camera doesn't move, obviously. And I'll just go to the right witness camera and I'll just add that point in as well. In fact, I actually forgot to add the third point on the first tracker, but I will add that in a second. But the idea is to get as many of these track points in as you possibly can, because PFTrack is going to use this to position all 3 of the cameras in 3D space. So here we are, I've positioned 14 trackers that are common in the clips. Some of them aren't common in all 3 of the clips, they might just be common in the main camera and the witness camera. You want to always reference them to the main camera and not the witness camera to the witness camera. So now we need to let PFTrack calculate the camera positions, so we've just right clicked the user track and add a camera solver, and again we're going to pipe all 3 of these points into the camera solver, and we'll just double click the camera solver, and I'm just going to leave everything as default just for now and see what happens. So I'll just click solve and take a look at things. So it seems to have tracked things quite well, but obviously it's only positioned the right witness camera, and I don't think it's actually positioned right. So we go to the errors tab and click trim, and just move this down a little bit, and this number at the side of the graph is the number of pixels each tracker has slipped out, and this is going to trim off the sort of trackers with errors on. So if you resolve it, it's going to change the look of the camera solve, and this looks a little bit better, but again it's not found out where that left witness camera is. So I'm just going to trim even more, maybe to around 3, resolve it, and there we have it. It's figured out the positions of all 3 cameras, which I think is pretty amazing really. So I'm just going to start to orient the scene a little bit, and to do that I'm just going to set the origin to a point that's on the floor. So I click that and click set origin. It's going to put the grid to the floor plane, which helps a lot. And if we have a look through the other cameras, you'll see that the grid is sticking too. So it seems like these cameras are positioned pretty perfectly. It looks like that grid is on the floor on this one as well. It's hard to tell, but it looks pretty accurate. So now I'm going to further orient the scene. So if I just right click the camera solver node and go to orient scene, and just again pipe all 3 of these into the orient scene node, and I'm just going to go to the orientation at the side and go to rotate, and just by eye I'm just going to move this to a better orientation. So I'm just using the skirting board at the back of the room to orient this. I mean, this one doesn't really have to be perfect because we're only interested really in the motion capture at the end. So that's looking pretty good to me. Looks like it's stuck to the floor pretty well. So the next thing we do is right click this orient scene and go to user track, and again we pipe all 3 in, and what we need to do here is the time consuming part. But firstly, the most important thing that makes the mocap work is we need to create a new group of trackers. So if I click the little plus arrow near current group, and I'm just going to rename that to mocap trackers, and now we need to track all the points on this piece of paper throughout all 3 cameras. So it's going to take a while because you're going to have to track the whole thing. Is there, how many is there? There's 15 trackers and you have to track them on all 3 cameras, so that's 45 full-length tracks altogether. So if I just let the auto tracker run through, it's obviously going to run into problems because it always does, but if that happens you can always stop its auto track where it slips out, and you can just manually place the tracker, and it's just sort of, that'll just change the keyframe of where the tracker went. So once you've fixed the position, you can just track forwards again and just wait for it to slip out again. If it does, it probably will. See, it's slipped out again. So I'll just go to the point where it starts to become a problem. I'll reposition that tracker, and that looks about right, and then I'll track forwards again. So you just got to keep doing this throughout the whole clip. You will get a solid track eventually because you can always hand animate the tracker. So even if the clip's super blurred, you can just manually keyframe, but again this will take a lot of time. So we're almost at the end of this clip. If I just keep manually positioning it, tracking forwards, it might stop at times, and that's because the error rating has gone too high. So PFTrack just basically stops the track once it's slipped out by a few pixels and it thinks that the track's gone wrong. So I'm just going to go to the left witness camera, and I'm just going to select the same point. So you can adjust the search radius by just clicking at the edge of these boxes and changing it to however you want, and you'll notice that the witness cameras will track a lot easier because the camera's not moving as well, so there's that extra level of motion blur that it's sort of not receiving from the camera. So you get the idea. You've got to track every point that you want tracking on all 3 cameras. So I'm just going to pause the video here and come back once I've tracked all of the points. because as you can see, it's going to take a while. So here we are, all the tracks are finished. They're all looking pretty accurate as well. You can see that I've tracked all of these on all 3 cameras. So it did take a while, it took about an hour. I missed out the top row because they went off screen on the main clip. So the next thing we need to do is add a Mocap Solver after the user track, and again pipe all 3 in. And what we need to do is click use input cameras, so it uses the position of our cameras to help the track. And I'm just going to set the start and end frames and just click solve all. And if we look through the perspective view, you'll see it has tracked it pretty much perfectly. You can see that the points are moving. We've got our camera solve and we've got these moving points, which is pretty amazing that you can do this all inside of one program. So what we can actually do now is go to image modeling, and if you wanted to make some geometry which follows these, we can do that. So I've just piped all 3 again into the image modeling node. So if we click this primitives thing with the little dots on, it's going to create a trackers object, and we can go to polygon editing and click connect, and we can connect these up and try and think about how they're going to deform. So I'm just going to connect mine as triangles, so we get a nice bit of deformation. So it's good to plan out how your object's going to deform and triangulate it accordingly. So just going through the whole thing, connecting them together, and this is going to create a piece of geometry that we can export into our 3D program. So nearly there. So yep, just adding the final ones. Oops, it's undone the last one. Amazing. But yeah, just creating little triangles where you want the deformations to happen. So think about that. And if we look through our 3D view, you'll see that our piece of paper is perfectly tracked, and we've got a piece of geometry which follows it. If you want to check the accuracy of this, if you go under the display type, we can go to textured, and that's going to project the paper texture onto the piece of paper. And you can see that the trackers are all stuck on there pretty much perfectly, which is exactly what we wanted. So now we need to think about how we're going to export this into our 3D program. So if we go back to the node graph, we can right click the image modeling node, and go to export, just find that, and again pipe all 3 in, and once you've done that, you can tick which objects you want to export. So you can see that our trackers object is there, which is our piece of geometry, and all 3 cameras are there, and we can just select the format we want. So the Autodesk FBX is pretty much the standard, and we can export that. But I did actually miss something out in the orient scene, and that's adding correct scaling. And to scale the camera solve properly, what we need to do is select 2 trackers and set the distance between them. So I need to go to marquee and just select 2 points, or I think I can click shift and drag over 2. Yep, there we go. And you can set the distance here. So this is dependent on the units of your CG scene. So if I put 1 there, it could mean 1 meter, it could mean 1 centimeter. So you need to check that out and maybe run some tests out. But there you have it. Once again, thank you for watching. This has been the YellowDog 3D Tips blog. Stay tuned for more 3D tips. Cheers.